Welcome back, mathematicians. In this video, we are going to learn about conjugates of complex numbers and how we use them in certain problems. So we start with the definition of a conjugate. So if we let z equal a plus bi. In other words, z is going to be our complex number a plus bi. Then the conjugate will be z, and we denote it with bar, with a line above the z. So we call that z bar is equal to a minus bi. And that is the conjugate of z, that complex number. So for example, if I said z is equal to 3 minus 2i, then the conjugate z bar will be equal to 3 plus 2i. In other words, the real part 3 will stay the same, but the imaginary part, which in this case is negative 2i, will change to its opposite, positive 2i. All right, so how we use this is that we're going to take this number 1 plus 4i, the conjugate number 1 plus 4i, over the conjugate number 5 minus 12i. And we need to rewrite this in the form of a plus bi. And to do that, we need to rationalize the denominator. So what we notice is that the denominator is actually imaginary. And so we want to turn this into a rational number. To do that, we're going to multiply by the conjugate of the denominator. The conjugate of the denominator is 5 plus 12i. And we're going to multiply both the numerator and denominator by that conjugate number, by that complex number, again, because 5 plus 12i over 5 plus 12i is equal to 1. So we're not really changing the actual value, changing the actual number, but we are changing the way in which it looks. So let's go ahead and apply the distributive property to both the numerator and denominator in order to get our final answer in the terms of a plus bi. So we start with the numerator, and 1 times 5 is equal to 5. 1 times 12i is equal to positive 12i. Then we have 4i times 5, which is equal to positive 20i. And then finally 4i times 12i, which is equal to positive 48i squared. This is all over. Now we're going to go ahead and multiply the denominator. So 5 times 5 is equal to 25. Then 5 times 12i is equal to positive 60i. Negative 12 times negative 12i times 5 is equal to negative 60i. And then finally, negative 12i times positive 12i is equal to negative 144i squared. So we got some simplifying to do. What we hopefully notice is that in the numerator, we have some like terms in both the numerator and denominator. We also have this I squared, and we need to talk about that for a second. We know that I is equal to the square root of negative 1, which means that I squared is equal to negative 1. So we're going to replace I squared with negative 1. Okay, let's keep it going now. So what we have in the numerator is 5 plus 32i plus 48 times negative 1 over 25. Now what we notice here is the positive 60i and the minus negative 60i do give you a difference of 0, so we don't even include those. So we have minus 144 times negative 1. Okay, let's keep it going then, and we have 5 plus, so it's going to be 5 plus 32i and then minus 48 over 25 plus 144. Finally, we are going to simplify our two sets of like terms. So in other words, we've got 5 and negative 48 in the numerator, and the entire denominator can be simplified to give us a final answer. So now we're going to simplify one more time, and what we get is negative 43 plus 32i, and you'll notice I put the negative 43 first, all over 169. Now, if we wanted to write this in truly a plus bi form, we would then split up these two numbers in the numerator and keeping the denominator the same. In other words, we'd have negative 43 over 169 plus 32 over 169i. And so that would be your final answer in the form a plus bi. All right, guys, good luck.